Very good morning to everyone. We were dealing with the preparation methods of alkenes. The most widely used methods are dehydrogenation of alkanes or dehydration of alcohols or dehydrohalogenation of alkyl halides. And the alkenes, like that of alkanes, belongs to the hydrocarbon series of the organic compounds. The alkenes are unsaturated compounds, whereas alkanes are saturated compounds. Alkanes contains the double bond which gives rise to a unsaturation. Because of this unsaturation, alkenes undergo different type of reactions. As we know, alkanes are most rugged species. They do not react at all. Why is it so? It's because of the fact that the carbon and hydrogens are having equal electronegativities. That's why the electrons are equally shared. It is like an employer and employee relation between a government and the government servant. In this case, the hydrogen, which acts as a servant, is satisfied with the government, which is represented by carbon. That's why the government officials become most rugged. Both of them are satisfied with each other. That's why they become less reactive or non-reactive. Whereas in case of alkenes, it has double bond in it. The one of the double bond is sigma bond, another is the pi bond. The pi bonds are in excess when compared to the alkanes, which has only sigma bonds in it. These excess pi electrons which are present in the alkenes makes these alkenes pi excessive system. This, if it is having excess electrons, then it is a nucleophile. That's why it becomes a nucleophilic center. As it is electron rich, it can donate that excess electrons to the electron deficient species, that is an electrophile. That's why it can undergo electrophilic addition reaction. In case of alkanes, it underwent substitution reaction, preferably the free radical substitution. Here it undergo addition reaction because it is having excess electrons in it. That electrons are shared with an electrophile and that it gets added up. It is something. Electrons are like money. If I have more money, more electrophiles or more relatives or more friends bond with me. And it goes on getting added up. That's why one should become rich to have more relations. The richness increases the relationship, like in that of alkenes. What all types of electrophilic addition reaction the alkenes can undergo is the subject of discussion for today's presentation. Many electrophiles can add up onto this pi excessive system that is alkenes. The hydrogen can get added across the carbon-carbon double bond. When hydrogen gets added across the carbon-carbon double bond, that pi electrons are shared with the hydrogen and it gives rise to alkane. This is called as hydrogenation of alkenes. That's why the one type of electrophilic addition reaction that the alkenes can undergo is hydrogenation. The halogens can also get added up across the carbon-carbon double bond, and this process of addition of halogen across carbon-carbon double bond is called as halogenation. When I add hydrogen across the carbon-carbon double bond, I'll get alkane. Alkene gets converted to alkane. As we have seen, one of the methods of preparation of alkanes is hydrogenation of alkenes. There, in case of alkanes, it is a method of preparation. In case of alkenes, it is the type of reaction that an alkene can undergo. The reaction of alkene is a method of preparation of alkenes. When I add halogens, I'll get vicinal dihalides. In case of preparation of alkanes, we took vicinal dihalides and dehalogenated it to give rise to alkene. Here, addition of halogens occurs across the carbon-carbon double bond, and this reaction is called as halogenation. Water molecule can get added up across the carbon-carbon double bond, and this addition of water across the carbon-carbon double bond is called as hydration, addition of water to give rise to corresponding alcohol. Another addition reaction, electrophilic addition reaction to be precise, which the alkene can undergo is addition of hydrogen halides, that is hydrohalogenation. Let us look into the addition of hydrogen, that is hydrogenation, how it occurs. Hydrogen, the electrons are equally shared and it cannot react so easily. Though alkenes are having the double bonds, it is by excessive system. Hydrogen here is not pi deficient system. It is as such not electrophile.